What's up, everybody? Mr. Kozad with another video lesson. We are going to today learn about solving systems of equations with three variables. This is kind of where Algebra 2 gets a little different than Algebra 1. In Algebra 1 you should have spent a lot of time solving systems of equations in two variables. Algebra 2 is really the first time you really get into systems of equations with three variables. So before we get going, our music for today, a group called the Civil Wars. I actually was turned on to the Civil Wars just a couple of years ago by a friend, and I just really enjoy their style. Very easy listening. Helps me kind of stay focused while I work. So here we go. Let's get going. Solve the system of equations. So what you should notice is different about this is obviously we have three equations and we have three variables. If you remember to the last lesson on systems of equations, one of the guidelines that we had was that the number of variables and the number of equations needs to match. Okay, so we have three variables, three equations here. So the only thing that's really different here is we're adding this variable z. Okay, now when we are done with this, what we're trying to find here is a value of x, a value of y, and a value of z that is a solution to all three of these equations. Okay, with systems of equations in two variables, that solution that we had, we'd write as an ordered pair, and it was represented as the point on the coordinate plane where those two lines would intersect. Well, that concept is actually the same here with systems of equations in three variables. We're just adding another axis to our coordinate plane. Let me explain what I mean. So first of all, this is an example of an ordered triple. This is what it looks like. It's really exactly like it sounds. You have three different coordinates. You've got an x coordinate, you've got a y coordinate, you've got a z coordinate. Okay? So this is what it'll look like. Again, very similar to an ordered pair. We just have three numbers. That's why it's called an ordered triple. It's pretty easy. Okay? So if we actually build the coordinate plane by dimension, our first dimension is, let's call it the x-axis. Okay? One dimension means you can measure one direction, left and right. Okay? So I can't go up or down in one dimension. I can just go left to right. When I add the second dimension, that's where we have our y-axis. Now instead of, in addition to traveling left and right, I can now also travel up or down. Okay? So the third dimension is really hard to show on the screen, but the third dimension is actually, the best way to think about this is if you have your x and y axis, left, right, up, and down, the z-axis is actually front and back. So a better way would be if I could actually grab this point and drag and pull it straight off the screen and shoot it straight through you right now. Okay, so it would imagine, literally if you imagine pinching your computer screen or your phone screen, whatever you're watching this on, and dragging that point and pulling it out straight towards you, and then grabbing it from the back of your phone or computer and pulling it straight back, that's what the z-axis would look like. Okay, so in other words, we've got x-axis is left to right, the y-axis is up and down, the z-axis is front to back. Again, it's not a perfect representation here, it's the best I could do, but if you think about that z-axis as being front to back, I think that would be helpful to you. So the location of this ordered triple, again, it's not going to be perfect, but I could go right 2, down 4, and then out from the computer screen 4 units. Okay, again, like I said, it's impossible for me to do that on here. It's kind of hard to represent, but hopefully you get the idea of the z-axis and what it means. Alright, let's get into the fun stuff. Okay, I hope that you are in a good mood right now because we are about to have a good time with mathematics. Make yourself comfortable, get a sheet or two of paper out, take some notes. This is the only example that we're going to do. This will be a little different than the last lessons. I'm not going to have you pause anywhere in this lesson because I'm going to walk you through this step by step, explaining what I'm doing, why I'm doing it, and how I'm doing it. So we'll actually go through this line by line together. Please try to not get ahead, only because I want you to understand the thought process behind what we're doing. Feel free to go back, and if you need more time, go ahead and pause it if you need more time, or you can go back and rewatch something if it didn't make sense. But like I said, we're going to go through this step by step together, and I'm going to explain the process of how we do this. Okay, so here we go. Solving this system of equations is going to require a lot of algebra. Okay, when we introduce that third variable, we complicate things significantly. Okay, essentially, there's a couple different ways that we can do this using either substitution or elimination. I am going to show you the elimination method today. But in class, we can talk about the substitution method if this method doesn't work well for you. Okay? Basically, how the elimination method works is we're going to take the system and we're going to eliminate one of the three variables. Okay? As I look through this system, the variable that jumps out at me as being the easiest to eliminate is z. Okay? Is z. So what I'm going to actually do is I'm going to eliminate z twice. Okay? Pick two equations that have z in it, and we're going to eliminate z from those two equations. So what I'm going to actually do is I'm going to take the first equation and the second equation. Hopefully you have this written down, because I'm going to shrink this down a little bit and move it just to give me some more space to work. Okay, so like I said, what I'm going to do is I'm going to take the first equation and the second equation, and I'm going to eliminate z. Okay, so the first equation, I need a marker, there we go. The first equation is negative x plus y plus 2z equals 7. And I'm going to use the second equation as well. But what I'm going to do is I need to multiply that second equation by 2. So I'm going to go through and I'm just going to rewrite that second equation, and I'm going to multiply it by 2. For those of you asking, well, why do we need to multiply it by 2? Remember, if I want to eliminate z, I need the coefficients to be either the same or opposites. Okay? Also, please make sure that you remember to multiply the 1 by 2 as well. That's a common mistake. Okay, so now what I'm ready to do is I'm ready to eliminate z. Now, ask yourself the question, do I have the same coefficient or opposite coefficients? You actually have opposite coefficients. I'm sorry, the same coefficients. So we have positive 2 and positive 2. If you have the same coefficients, we're going to subtract, because again, our goal is to have 0z. So when I subtract across each column, or down each column. So I've got negative x minus 4x to give me negative 5x. And then I have positive 1 minus 6 for minus 5y. The z's cancel out, so I have 0z, which is what I wanted, and 7 minus 2, I get 5. If I clean this up just a little bit, I get negative 5x minus 5y equals 5. Some of you might be wondering why, or if it's necessary to show the 0z, and my answer to you would be it's not necessary, but I like to do it just to make sure that I'm adding or subtracting correctly. It's kind of an easy way to check to see if I'm doing everything right. Okay? So I've eliminated z one time. So what I need to do is I need to go back to the original system of equations, and I need to find a different pair of equations. I used 1 and 2, so I need to take a different pair and eliminate z a second time. So the most natural would be 2 and 3. So I'm going to take equations 2 and 3 next. So the next thing I'm going to do is take equations 2 and 3. So I have 2x plus 3y plus z equals 1. And then the second equation, I have negative 3x minus 4y. That's supposed to be a 3. I know it's ugly. Don't judge me. Plus z equals 4. Okay? Now, I don't even have to do any multiplying here because my coefficients are already the same. Their z coefficients are 1 and 1. And remember, since the sign is the same, I know I'm going to subtract. So I'm going to go through each column and subtract. So I have 2x minus negative 3x. Well, minus negative 3 turns into plus, so that ends up being 5x. Then the second column, I've got 3y minus negative 4y. That turns into plus 7y. And then we have 0z, which is what we wanted, and negative 3. So if I clean that up a little bit, I've got 5x plus 7y equals negative 3. Okay? Now look at what we have here. We've just rewritten this system of 3 variables. We've gotten it down to being a system with 2 variables. And hopefully you're pretty comfortable with how to solve these. Okay? So essentially what I have now is if I combine those into one system, I've got negative 5x minus 5y equals 5. A lot of 5s. 5x plus 7y equals negative 3. So this is my new system. Okay? So what we're going to do is we're going to take this new system and we're going to solve it for x and y. So let's cut that and paste it over here. Let me move this up here. Okay, so hopefully you remember from last class, and even from Algebra 1, solving for x and y here is actually, it should be pretty easy for you. Here, I don't care if you use substitution or elimination. It really doesn't matter to me. I would argue with you that elimination is the best method here, only because my coefficients of x are opposites. So really what I could do, marker, really what I can do is I could go through and add these equations, and that would eliminate x right away. Okay? So negative 5x plus 5x gives me 0x. I have negative 5y plus 7y, so plus 2y, equals 2. Alright, then we clean this up, we get 2y equals 2, and very clearly we have y equals 1. Okay, now that was a lot of work to simply find one variable. But once you the hardest part of solving systems of equations with 3 variables is solving for the first one. Because once you have the first one, all you have to do is substitute it back in one of these 2 equations that we have, and that'll let you solve for x. Okay, so let's take this first equation here, and let's substitute 1 in for y. And let's clean this up a little bit. So we've got negative 5x minus 5 equals 5. Add 5 to both sides, so we get negative 5x equals 10. Divide both sides by negative 5 equals negative 2. Make sure when you divide by a negative, remember that you have to flip the equal sign. Okay, if you actually flip the equal sign, flipping an equal sign looks the same. That was supposed to be a joke. Don't actually flip the equal sign. Okay, moving on. I promised you there'd be one lame joke in every lesson. Okay? So here we go. We've got our x value and our y value. Now all we need to do is find our z value. So to do that, it's actually really easy. You go back to the original system of equations, and you pick any one of these equations that you like. Any one of the original 3 will be just fine. Okay? I'm going to go ahead and just pick the first one. So I take that first equation, and I paste it in here so we can see it. Okay, I take that first equation, and I'm going to plug in my x value and my y value and solve for z. Okay, I'm plugging in my x value and my y value and solving for z. Okay, so I've got x is negative 2, so we've got negative, let me get the pen, there we go. We have negative 2 plus 1 plus 2z equals 7. Okay, if we go through and clean this up a little bit, we get 2 plus 1 plus 2z equals 7. That's 3 plus 2z equals 7. Subtract 3 on both sides, so we get 2z equals 4. Divide both sides by 2, and clearly we get z equals 2. Okay? So there you go. You have all 3 values. The last thing that you need to do is make sure that you go in and write your solution as an ordered triple. So our solution here is negative 2, 1, 2. Written as an ordered triple. That, ladies and gentlemen, is awesome. That is why we love mathematics, because look at all that awesome work we did to solve this system of equations in 3 variables. You should be proud of yourself. Pat yourself on the back. And I hope that you are excited to come to class, next class period, because we're going to spend the entire class period practicing solving systems of equations with 3 variables. Okay? That's all I have for you today. I'm excited to see you next class period. Come ready to work. All right. Enjoy the rest of your evening or day, wherever you are, whatever you're doing. All right. Talk to you all later.